talking about chain rules for functions of several variables. So suppose I have a function of two variables, okay? And both the x and y are also a function of another variable, okay? So let me give you an analogy for a single variable functions. So in Calc 1, this is what you learn. Y equals f of u, right? Just like this. Z equals f of xy. And the u itself is a function of another variable. Okay? So don't be obsessed with the name. Just need to know that this is an input variable in this function. And the u itself is a function of another variable. Okay, so don't get confused by the x, y, f, g, u, stuff like that. So this together tells you y is f of g of x. So it is a composite function. Right. So in here, z is f of x. X is g. Right? So you are seeing a function composite another function, and y is also a function of that same variable. So here you see the composite function in the case of multivariable. All right? So in this case, when we want to differentiate this function with respect to t, what is the formula? What is our chain rule here? So this is the chain rule. dz dt is equal to dx dt times dz dx times dx dt plus dz dy times dy dt. Okay, so now this formula looks a little complicated. So we're gonna use a diagram to help us memorize this formula. Okay, so I'm gonna start from the outer function. Okay, whatever goes the outside is the outer function. So I have z, that is the outer function, like what eventually I'm going to get. And z is a function of two variables. So I have x and y as the input variables for the z. Once I have the value for x and the value for y, I would know what z looked like. Now, x is another function of t. Y is also a function of t. So what you do is, when you see this stick, it means you differentiate z with respect to this variable. Okay? And because you see, under z you have two variables, so you are supposed to use this notation for partial derivatives. Okay? And same here, you have dz dy. And we're using this notation because it's a partial derivative. All right? And now we move on to this stick. This is a stick connecting x and t. So I differentiate x with respect to t. Now you see I'm using the regular d as opposed to this weird d because down below x there's only one variable. So I'm only using the regular differential notation. Okay? And same here, under the y I only have one variable, so I'm using the regular notation. All right. So now, whatever that's on the same path, you multiply together. This is on the same path, you multiply together. And when it's on different branch, you eventually add it up. Okay? So what does this mean? On this along this branch, you have dz dx times dx dt. So this is what you get If it's along the same branch, you multiply them together. So over here you have dz dy times dy dt. Okay, so now the two different branches, so you add them together. So down here what you have is, well, how do you differentiate z with respect to t? Differentiate z with respect to t. So this is dz dt. Okay. So now you can use this diagram to help you apply the chain rule formula. So let's use this example to practice chain rule. I have a function of two variables, x squared plus y squared. X itself is a function of t, y is another function of t. And I know if I want to, I can write z as a function of t, just plug these functions into the x and the y, like how you do with composite functions. Now, let me apply the chain rule. So so we have dz dx is derivative of this function with respect to x. So that's 2x, right? dz dy equals 2y, because I'm treating x as a constant and focus on differentiating y squared. Okay, I need more than that. I also need to know this and that. So I have dx dt equals, now I differentiate that function. What's the derivative sign? Derivative sign is equal to cosine. Okay, and I'm differentiating this function. Derivative of y is equal to minus sine. Okay, so now I have all the ingredients I need. I just need to put them in place. So I have dz dt equals 2x times cosine t. dz dx is 2x, dx dt is cosine t. So 2x times cosine t plus 2y times sine t. Remember, after I apply this formula, I need to convert everything to the final variable that I'm looking at. So what does that mean? Final variable means the variable that shows on the bottom of the diagram. Okay, so I want to convert. I want to write x in terms of t. I want to write y in terms of t. Okay, so now this is equal to 2, what is sine, x is the sine function, so 2 sine t times cosine t plus 2, what is y? Y is cosine t, so 2 cosine t times minus sine t. And you see that this is 2 sine t cosine t. This is negative 2 sine t and cosine t, so they cancel each other. That tells you dz dt is equal to 0. Okay, so this is a special case. The derivative is equal to 0. All right, so I wanna give you another perspective for this derivative. Okay, so you can say, like, what if I don't care about the chain rule, and let me really write down the composite function. So x is a function of t, y is a function of t, and let me do plug in. So I have x squared plus y squared. What is y? Y is cosine. Okay, And over here we have sine squared plus cosine squared. So trig identity tells us sine squared plus cosine squared is equal to 1. All right. So when z is restricted onto sine t and cosine t, z is equal to a constant. So no wonder the derivative of z with respect to t is equal to 0, because derivative constant is equal to 0. Okay. So in this case, you might think, oh, why don't I just do this approach, like just plug everything in and then just differentiate the function as before. But sometimes this approach is not necessarily a better approach, and in general, chain rule will be a much better tool to help you solve more problems. Okay, and another thing that I want to mention is the graph. So z equals x squared plus y squared looks like a paraboloid like this. Okay, goes up, like that. Okay, like a paraboloid. Now x equals sine squared, y equals x equals sine of t, y equals cosine of t. That means they travel along a unit circle. Okay, and so this is a unit circle on the xy plane. Okay, because I'm trying to tell you what the x equals sine t and the y equals cosine t is like. Okay, so it goes this way. This is x, this is y, right? So you can think that x equals sine t, y equals cosine t gives you a curve in plane. Now I restrict z onto this curve. So what does that mean? That means I only look at the part of the surface that's sitting right above this circle. Okay, and I happen also to see just that circle on this paraboloid. So that's why in this case, all the points on this circle will give you the z value equal to 1. Okay. Of course, when I have different surface, suppose my surface goes like from high to low and then go up, and I restrict this surface onto a small circle, then the curve I will see will be like this. Okay, for example. All right. So just to show you different ways of differentiating composite functions of several variables. This is our first chain rule, very important. Okay.